Alrighty, let's see what we got today. Maximum erasure's value. You're given an array of positive integers, nums, and want to erase a subarray containing unique elements. The score you get by erasing the subarray is equal to the sum of the elements. The score you get by erasing. Okay, it has to be unique elements. Okay. Return the maximum score you can get by erasing exactly one subarray. Array B is called a subarray of A if it contains a continuous subsequence of A. That is, basically has to be connected values within the array. Okay. And all the values have to be unique. So 4, 2, you could erase, you could do 2, 4, you could erase all these. Can't erase that because there's 2 4s, so it has to be like there. And obviously this one would probably be better than 4, 2. Okay. And then I guess you can call it erasing or just actually just taking out. So this one I think it might be 8 or 8 or 8 or 8. So there's a bunch of ways of getting 8. I mean, there's only 3 different numbers, so I mean, can't have a duplicate. Okay, so I think here it should be pretty straightforward in terms of maybe using a sliding window technique. You slide the window out to the farthest that you can. Probably keep track of what elements you have using a set. So let's say you have the sliding window. You either have the left side fixed or the right side fixed. Generally, I like to use the right side as the incrementing index in a for loop, and the left side closes. So I think left is going to be equal to 0. Going to need to have a set of uniques. And I'll probably just have an answer for every index in the range of n, where n is the length of the numbers. So it's always, in general, for sliding window technique. So you start by expanding the window. No. Yeah, you start by part 1 is going to be expanding the window on right, the next value, kind of. So it's going to be values equal to nums at this index. And I will, the value should be added to the uniques, I want to say. Uniques dot add this value. What happens if there's a duplicate? So if you add, so you expand, add 4, add 2, add 4. Maybe you need to close. Maybe you need to close the window for the value first, actually. So let's see. You have 4, 2. If you expand it, add another 4. How do you know to close the window? How do you know to close the window? I guess you probably need to check to see if the new element is already found inside the previous window. And if it is, then you kind of need to remove it from the left side. Okay, I think I need to maybe a boolean here. as val is equal to well, not the values in the uniques already. Okay. Then, so if it does have the value, then you need to remove stuff from the right side, from the left side. Kind of close the window. So it's going to be while has val is while has value is false. I think you'd want to take whatever is the left side value. The value is num's at the left index. And remove that value from the uniques. If the left value, no, you want to do that until it actually is the duplicate value. So I guess you should do that still. Maybe I should probably do this. I should probably make an estimate before this. If the left value is equal to the value that you're trying to remove, then don't remove it, just break, I want to say. Else remove it. The reason why you break there is, like, let's say you have the Windows 4.2, you expand it to be 4, so there's a duplicate 4 there. So you remove the left side, but as you move the index to the left side, you don't actually want to say that 4 is out, is no longer part of the set of uniques. 4 should be still there. You just want to break. Yeah, okay, I think that's right. And then once, so first thing for the sliding window is to expand the right side. And then part 2 is to how do I say this? Expand, close window on left to maintain close window on left until Windows satisfies required property. In this case, the required property window must have strictly unique values, no duplicates. So thus remove move left side of move left index thus if added value on right is duplicate, remove left values until no duplicate. Okay, I think that's it. And probably should be keeping track of the sum. Yeah. That sum is 0. Expand the value. current sum plus equals the value. And when you do left side, you're removing it each time. Current sum minus equals the left value. And now right here is part 3 of the window, which is evaluate the window, update answer as appropriate. So the window is currently some set of uniques. That is the longest that you can have up to the right index. So it's going to be answer equals max of answer and the current sum. And after loop, just return the current, return the answer. I think this is right. Or it just could be very, very wrong. 4. What's going on? Index. Current sum. Increased by the value. The value is already in your. Oh, whoops. This is the wrong freaking order. Wait, no, it's actually. That's the right order. Has the values, this already there. While. Oh, I never actually. It's kind of a wild true loop, it looks like. So I never actually changed the has value. No, it shouldn't be while true. While not has val. I think this is the wrong. It's the wrong logic. Oh my god. That's pretty sad. It's the opposite logic. Okay. Alright. Let's see if I can't maybe improve some of this. Makes this set left index current sum. I don't know. Maybe I should reorder some of this stuff. Actually, never really know how I should be ordering the random variables that I create. Answer current sum left. I guess that's alphabetical. Further index. I wonder if I need to go by index. Can I just go by value with for loop? With the for each loop? I think maybe. Yeah, so that should be fine. Further value and range. In nums, change it from an index loop to for each loop. Done this. Current sum increases. Generally, you, if you have if there was some condition that required you to keep track of the length of the window, like the subarray can only have 5 entries or something, then maybe you would need to know the actual indexing of the value that you're dealing with in the for each loop. So, but here there's nothing that actually requires me to know what the right index is compared to left index. Just has value. Maybe I should say this is has duplicate. Has duplicate. like that. This is kind of weird that I have a boolean for the duplicate. Wonder. Maybe the better way of doing this would be to actually put this afterwards, because I always want this to be added. And maybe this should be while value is in dupes. While value in uniques. Gets rid of this boolean. Like, yeah, this is fine actually. So left value, increment the left index, remove it from the sum. I think actually you could do something like this. Uniques.remove left value. And then recheck. Okay, I think that's fine. I'm not sure if it's actually any faster. Hard to say if anything's any faster given that the random variation of the runtimes is generally higher than the changes of higher than the actual higher than what you might expect changes in the code to actually produce. Okay, but that seems pretty condensed. So while this value that you're at on the right side is in your unique set, close the window on the left side with whatever left side value there is, and then finally add the value again. Yeah, okay. I think this is as good as I'm gonna get it. Runtime actually wants slightly worse. Okay, anyways, summary, this is gonna be as straightforward forward sliding window technique. And this is going to be maintain a window that has strictly, I'm not sure what, has unique values. And yes, use a for loop to incrementally add right side values to the window. If added value breaks the window condition, window condition being all uniques, move left left index of window until condition is restored. Every change to window, adding, removing elements should affect the sum, the tracked sum. And and set of values. Use a set to keep track of uniques. So you can assume that basically the set is all uniques, and only time where you don't have a unique or you're adding something that would duplicate is when you need to move the left side. So you add something, the values already in your unique set, then you remove the left side. And then also at the end of each loop, compare answer to current sum of window and update appropriately. So if the current sum is higher than the current answer, then you should increase the answer. Return answer after loop. And in general, sliding window technique will have something like left equals answer equals 0 for right index in range of n. Value is equal to right. And then there's going to be some code to add value to window, which can break the window property. And there will be a while window is broken, you're going to have to do something, remove left value from window, and then here after this, after loop is update answer with new window, with current window. So something like answer equals answer or new update new window value, like sum, and return the answer. So that's kind of main pseudocode for sliding window stuff. Yeah, time complexity, this can be O of n for O of n for iterating over each element of the array. The calls to add and remove stuff from the unique set should be, or calls to add, remove, or check should all be constant, since that's how sets work. Calls to add, remove, and check. Check existence with set, unique set. Check existence value with unique set are all constant. Constant time. Yep. And then space complexity is going to be O of n to maintain the current window set, which in theory could include all the elements of the array. If the array was strictly all uniques, then you'd have all the values inside that set. Alright, cool beans.